Hey guys, what's up? We're back for more Algebra 1 stuff in this e-learning edition. So, for today, once again, Group A, Group B, whether you're first 9 weeks, second 9 weeks, we're still going to do this, right? So, on our docket for today, we're going to watch the video in Canvas. Hopefully you find it. Don't forget. Hopefully, if you're watching this video, you did find it. If you know someone who hasn't found it yet, make sure that they go to the home page, go to modules. This will be in week 1, I'm pretty sure. This is the end of week 1. And yeah, it should be on the Friday page. Or on the Monday page if you're on the B group. So, this is the video. We're going to go through evaluating expressions. Should be fairly easy for you guys. I know it will be. We're going to complete the problems. Well, you're going to complete the problems, not done in the video. It will be very easy. We've got something like 6 examples, but I really want to leave as much for you as I can because this stuff is going to be important. So I'm going to go through some of these problems with you. You're going to finish the problems I don't do in the video, and then I want you to upload these in Canvas or show me in person that you've done the work. All right? So without further ado, let's get into it. So expressions. It's important to know what an algebraic expression is. And if you'll notice, I've got my notes here because I don't have everything laid out. So don't worry about the backside. There's nothing there. So 1 page of notes for us to get through, 6 examples and several definitions. Yes. Algebraic expression. What exactly is an algebraic expression? It's important for you to know exactly what this means. And an algebraic expression is nothing more than a mathematical phrase. So, a mathematical phrase.
Ashley Hire to the main entrance, please. Ashley Hire, please come to the main entrance.
Ooh, she's in trouble. Ha ha ha. Sorry, I spelled mathematical wrong, as I like to joke. This is why I am a math teacher, not an English teacher. This is a mathematical phrase made up It's made up of numbers and variables. I say again, a mathematical phrase made up of numbers and variables. We've already seen some of those yet. We've seen mathematical phrases that just have numbers. Now we're going to throw in some letters. Don't be afraid of those. Those variables are key to math, in algebra especially. And all a variable is an unknown quantity. It's like the number of gallons I'm going to fill up at a gas station. I know that it costs $2 for a gallon of gas, but how many gallons do I buy? That's going to be the variable. That's just an example. It's something we don't know yet, but algebra seeks to solve for it. So, for example, if we're looking at the substitution property, this thing is going to be very handy. It's going to be what we do. So, suppose if A equals B. I know these are 2 letters. Let's just go with it. Trust me on this. If A equals B, then A may be replaced for B in any expression. Let's write that out. A may be replaced for B. A may be replaced for B in any expression. The evolution of my handwriting has come a long way. So, basically substitution is what we'll be doing a lot of. We'll say that maybe this variable equals this number. And we'll see these in an example. So, to evaluate an expression, wait a minute, did I read that right? To evaluate an expression, variable replacements. We're going to start out with this. I'm trying to make sense of that myself, so if you're confused, don't worry. You're not the only one. All right, so bullet point. We're going to start with this, substitute. Substitute. Substitute the variables with their given values. More times than not, when we substitute in, we'll say like x equals 3, and we're going to take that 3, and we're going to plug it into wherever we have x in an expression. Each time you substitute a variable with a number, put parentheses around the number. Parentheses. Put parentheses around that number. That way we know what we've subbed for. We know what the substitution was, right? And I'll show you how we do that. These steps are good to follow, right, though? Start with the substitution, put parentheses around the number you subbed in, and then last but not least, follow the order of operations, hence what we just did. Follow the order of operations. This is what we're going to do to evaluate. See how we just build up. We started with order of operations as like the first fundamental piece of Algebra 1. Now we're doing order of operations when we have a variable in there, and we're just going to substitute it in. We're adding one more step, essentially. That's all we're trying to do. So, here we go. Let me go ahead. I'm going to erase this. If you need to write some down, pause it, then come right on back. All right? So, with my handy-dandy fiber rag, I make it all disappear. I'm a magician, maybe a mathematician. This is what we're going to do, because all this is really is an extension of order of operations. I trust you guys. With these two examples, I'm going to show you how to do it. The last four are you try. Literally, I want you to you try. That sounds like a whole bunch of redundancy. All we're doing is we see what has been given to us. So in this case, our expression is this. It's a times b squared plus c. That's our expression. Now over here, they tell us what each variable equals. So a is equal to 2, b is equal to 4, and c equals 7. Remember that first step that we're going to use? We're going to substitute in the known value for the variable. So where I see a, I'm going to put 2. Remember that part about parentheses? Let's start that. A was the first term in this expression. I'm going to put a 2 in parentheses. Now b. B is equal to 4, right? So I'm going to take that and plug it in. There's one thing I want to be careful about here. Notice that the b is squared. Keep that squared outside the parentheses, right? Then we're adding on c. And c was 7. We've substituted in our values for their variables. Now we can use the order of operations to finalize the deal and simplify the expression. So, first things first, parentheses. Well, there's parentheses everywhere. Let's ignore those and move on to exponents, because I definitely see this. 4 squared. That's what it is. It's 4 squared. What is 4 squared? Hopefully you're saying 16. So now I have 2 times 16. I'll keep that in parentheses. Plus 7. Following the order of operations, there are no more exponents. Let's do multiplication or division. Do we have any? Absolutely we do. We have 2 times 16. Remember that when I underline something, basically all I mean is this is the next step that I'm focusing on. 2 times 16, what is it? That's 32. 2 times 16 is 32, and we're adding the 7. 32 plus 7, 39. That's it. That's all there is to this. It's, like I said, order of operations with one more step. All right? Hopefully you are doing this in less space than it takes me. I am writing a lot here. Hopefully you write better than I do. All right? Secondly, now we've got a real mathematical expression, because not only do we have letters, we now also have numbers. I've got 3x squared minus 4x. Don't let it intimidate you. Don't do that. I know you're going to get intimidated by this, but don't do it. Remember, step 1, let's substitute in our known values for their variables. What do we say over here? X is equal to negative 2. Let's do that. Take that negative 2 and plug it in wherever you see X. All right? Remember to put parentheses. So 3 times, in parentheses, I'm going to have that negative 2. Don't forget, because of the exponent, I want it to go up out here. So here's the 2 minus, I'm going to take that 4 and in parentheses, -2. Now let's do this bit by bit because I know it's a lot. There's a lot here. Order of operations. Are there any parentheses? Yes, but they're not the kind of parentheses we need to worry about. So we're going to move on to exponents. What exponents do we have? We have -2 squared. I'm going to write this for your sake because I know it's going to get confusing and I don't want you to do it. -2 squared is not -4. Don't do that. For our step, I'm going to draw an arrow. I'm going to say, hey, what is it? -2 squared is the same as writing -2 times -2. That's what I'm writing. -2 times -2. Now the question I ask, what is that? Well, you have the negative times a negative, which is a positive, and you have 2 times 2, which is 4. So -2 squared still comes out to be 4 because the negatives are going to cancel. Then after that, I've got 3 times what this was, because I did this, 3 times 4 minus 4 times -2. I'm about to pull a double whammy. I'm about to do 2 steps in one, but you can do the same thing. It's simple enough. We've gotten rid of the exponents. We didn't have parentheses to begin with. Now we move on to multiplication or division. The great thing about this, the reason I can do 2 steps in one is because really the multiplication steps are split into 2 pieces. I've got 3 times 4, and that is totally separate from 4 times -2. Okay? So I'm going to do this first. 3 times 4, that's 12. I'm going to bring down the minus. Don't forget to bring down the minus. That's what this is. Minus 4 times -2. Well, 4 times 2 is 8. So if I have a negative, it must be -8. And I'm going to put this in parentheses because now I've got minus a negative. If you're a bit confused by this, let's put it in a real-world idea. Suppose that I owed someone, let's say that I owed someone $8, the -8. You'll have heard of credit cards. You know what credit cards are. When you use a credit card, you basically rack up debt. It's money you owe, and so it's a negative amount balance. So suppose that I owe someone $8. I have $12 in my wallet. I owe someone $8. Now what this minus is saying is it's taking away. So this is like saying I have $12 in my wallet, and I am taking away a debt. It's like the dude decided to say, hey, you know what? Forget about that $8 you owe me. Don't worry about it. Keep your money. Now all of a sudden, I'm taking away debt. That becomes positive. So negative minus a negative, minus a negative becomes a positive. So it becomes 12 plus 8, which I know you all know. It is 20. See, I know you've got it. All right? Make sense so far? All you're doing is the same steps that are up above in the notes. Use those notes. Substitute in the known values for their variables. Use the parentheses, and then use the order of operations. It's not meant to trick you. It's just meant to challenge you. All right? Ladies and gentlemen, this is it for now. Hopefully you guys are going to have a good weekend, or you had a great weekend coming into this, and I hope that you're having a jolly old time with this. So, until I see you again, have a great day.